Let's take a look at question 4 in this video. So the management of a computer store designed an incentive plan for its salespeople. Now 12 salespeople were selected at random to evaluate the plan, and their weekly incomes before and after the plan were recorded. So we have here the before column and the after column. Now we believe that the weekly incomes are not normally distributed. Let P be the probability or the proportion of salesperson that increase their income after the plan. And the hypotheses are that P, that proportion of people, is 0.5, and the alternative is that is greater than 0.5. The P value of the corresponding sign test is going to be 0.035, true or false. So they already told us that we're doing a sign test. Let's understand what's the intuition of the sign test and why we're not using a regular t-test on differences between means, because we have two groups where we could take the average income over here, and then we would take the average income over there and take the differences, but that's not good enough. Why is that? Because they are not normally distributed, and an assumption of the t-test is to have normal distribution. So the sign test is protecting for that. The sign test we're using when we have non-normal distribution. So we use it for not normal distribution. Not normal distribution. First of all, let's understand why would that be the case? Like, why do we not care about normality for the sign test? Because in a sign test we're just going to look at the differences between the observations, whether they are positive or negative. So because we're not looking at the extent of the differences, how big they are or how small they are, we are not interested in this normal distribution because we're not working with actual numbers. The distribution happens when we have frequency of data, remember? So if we have here frequency of certain observations, let's say this would be the income of the people, and we would have a normal distribution. That means that, let's say, the average income of a salesperson is going to be $2,000. That would be the mean, and that would mean that most salespeople are going to have $2,000 in income. So we deal with actual numbers. But when we take differences between incomes and we're dealing just with positive or negative differences, then we cannot draw such a distribution because we're not interested in how much that difference is. So the normality assumption goes away. We're not dealing with it. That's why we're using the sign test. So how does the sign test work? We're first of all taking the differences between groups, because our hypothesis is that we're not having higher income for the salesperson after the incentive plan. So we are expecting to have a higher income after the plan, because that's what we did the plan to begin with. We want the salesperson to have more incentive to sell more computers, and we want to know whether that's true or false. So we would like to have here more positive differences, but we're gonna see if those differences are big enough, if we have many positive differences enough to claim that indeed the plan worked. So let's take the differences. Again, we don't look at the numbers, we're looking at the signs only. 340 minus 320, well, that's bigger, that's a positive difference. 285 minus 290, that's a negative difference. 475 minus 421, that's a positive difference. 510 minus 510, that's a 0. 210 minus 210, that's a 0. 500 minus 402, that's a positive difference. 631 minus 625, positive difference. 560 minus 560, 0. 365 minus 360, it's a positive difference. 431 minus 431, 0. 525 minus 506, positive difference. 512 minus 505, positive difference. Now when it deals with the sign test, we have to count how many positive differences do we have. So we have 1, 2, 3, 4, 5, 6, 7. We have 1, 2, 3, 4 zeros, and we have one negative difference. The zeros are called the ties, meaning we're going to get rid of them from our sample. So our sample data is going to have only 12 observations minus the 4 ties. We're going to have n equals to 8. And the reason we do so is because we needed to calculate our probability in the binomial distribution. So this is how we interpret the data. We have 7 positive differences and 1 negative difference. How do we read that? Well, now we want to find out the p-value, and the p-value stands for a probability. What is the probability that we have at least 7 differences, at least 7 positive differences out of 8, by chance, assuming that we would have a 0.5 proportion of positive differences. The 0.5 stays for the fact that under the null hypothesis, if we have a symmetrical distribution of positive and negative differences, we expect to have a 50% positive differences, 50% negative differences. But we have here a tendency of positive differences. We have 7 positive differences versus 1. We want to see if this is significantly different from the 50-50% distribution. Hope this makes sense. So we want to find out the probability that we have at least 7 positive differences by chance, which is going to be the same as the probability of having at most one negative difference by chance. I hope this will the vocabulary, the words are going to make sense here, because that's the whole point of the sign test. How do we read the differences, which are at least and which are at most? So it's either having at least 7 positive differences out of a sample of 8 observations and the proportion that we expect under the null hypothesis 0.5, or we could read it as having at most, so k must be less than or equal to 1, at most one negative difference. So we have one negative difference. It's very unlikely to have a negative difference. So what's the probability that we have at most this one happening by chance? That's how we read it. N equals to 8, and that would be 0.5. And if we look in the distribution, in the binomial distribution, they're going to give us the same probabilities. We're going to have 2 results over here. Hold on, let me zoom out because we need some space. So over here we would have the following. We would have the probability of having 7 and then the probability of having 8. So that's going to be sorry about that, 0.0039 plus 0.0313. 0.0313, and these exact same numbers we're gonna have over here, because this is reading the same results from 2 different perspectives. If we have 7 differences, which is most common, what is the probability that we can have at least 7 such differences? What is the probability that we're gonna have 7 or even more, because it's so likely to have them? And the same analogy here, if we have only one negative difference, what's the probability of having at most this negative difference? Because it's very unlikely to have it. So if we work out the math over here, we add the probabilities, we're gonna get 0.035. 0.035, that's the probability corresponding to a one-sided test. And our test is one-sided indeed, because under the alternative, p is greater than 0.5. They say it's 0.035, that probability, so the answer is true. And if this was a two-sided test, if we had this in the alternative, we would multiply that by 2. Anyway, hope this makes sense, and we are done.